So I knew it was coming, and it still got me. It
Don't
tricked
get
me
you.
this time. It showed me our faces for a second, then
Yeah.
it did.
Well, it's been a while since we've had one of these.
That it has. Well, hi, hey, hello, everybody. Thanks for joining us for another Threat Thursday live. I know it's been a little, probably what, over a month now at this point, right?
Yeah,
May got
definitely over a
busy.
month.
Yeah, May was a lot. There's a ton going on, but we're back now, and we wanted to touch on a topic that's been coming up a lot lately. We're getting this question from people that work with Scythe and people outside of it in our workshops all over the place, asking how are we emulating nested campaigns, I guess is the best way to say it. So like a threat actor bringing in a stage two or another payload and having that kick off and do other things. So we figured we'd take today and show you guys how we do it in Scythe. We're going to show it to you several different ways. Some of them might be pretty simple using PowerShell, stuff like that. Others, we're going to do a little bit of process hollowing. So all in all, this should be cool. You'll get a chance to see how it works in Scythe and potentially learn something new.
Yeah, for sure. I say, and by dropper campaigns or excuse me, by nested campaigns, it's very akin to like a dropper campaign. Essentially, you have one campaign or implant or binary, whatever it is, that will perform some actions, and then via multiple different means that we'll showcase here in a second, download another binary or implant and then launch that. So it should kind of mess with like the process tree a little bit, look like it's coming from somewhere else. It's just almost a more stealthy way. You don't want one implant to do too much stuff, so they kind of have it broken down into like one will perform some actions on objectives. If those are met, then download or ingress tool transfer of an additional binary or implant, and then run that.
And now these methods we're going to show them too. They're not just tied directly to Scythe, right? It's not like we can only kick off another Scythe campaign. These are set up to where you could realistically replace whatever dropper we're using with an alternative C2. It could be something else that calls out somewhere else. It could be something from Cobalt Strike or Empire and Star Killer. I believe we use one of these functions in our updated Fancy Bear threat we made this time last year. I want to say actually that does something similar, right?
Yeah, for sure. I say, yeah, this isn't only set up for how Scythe works. I mean, even you can have additional tooling or binaries or campaigns or using other C2s to do it, and a lot of the same kind of almost technique that we're going to utilize to run these, you can do via other means outside of Scythe as well. But with that, let's kind of get into it. So we have three campaigns that I already made and ran. We have the dropped, which is going to be the additional actions or the campaigns that we're going to download and run after our initial dropper campaign. So we'll get into the dropper campaign first. So in here, we'll just kind of go through what it's doing and then show you what that looks like in Scythe and how you can set it up. So this campaign, initially, we wanted to go in, just do some simple enumeration, just kind of get a lay of the land of what our endpoint is. Want to make sure that it's able to reach the internet because we want to have that before we do the additional campaign that we have listed out for it. So the first way that we're going to nest or to drop an additional implant is going to be just via the C2 ingress tool transfer. So what we mean by that is we're going to download this implant, this drop.exe. We're going to download this directly from Scythe. And then once we download it from our virtual file system, it's going to be put down in the user profile in their downloads. We're not trying to do any obfuscation here because we're just kind of demoing, some different mechanisms or ways to go ahead and accomplish that. So we'll just call it drop.exe, keep it easy. And after we download it, and we'll go in, we'll just tell PowerShell, hey, run this campaign or run this executable that we just dropped, right? And a way to get that set up or staged in Scythe, and this should be pretty similar to a lot of other C2 platforms that have some kind of virtual file system or something like that that's available to it. So we'll take the campaign that we want here, just do a little checkbox, and we'll download it. We'll download it as an exe. And then from there, we'll go to the virtual file system. We'll go to shared. This is stored inside of our PTE directory here. And this is where we're storing these binaries that we're going to download. So we have drop.exe here inside of the virtual file system, and that's how we call that down onto disk, right? So this is going to look a little different in the logs because we're not doing a Sorry, I didn't realize that I'm out of focus over here. Um, because we're not going to reach out to the internet, or we're not going to run any additional PowerShell commands or things like that to download it like we'll do in these next steps. This is going to pull directly from an already established C2 channel. So it's going to be a little bit harder to detect kind of where it's coming from, or maybe how it got there, right? And we'll show that. We have some logs that we'll show here in maybe 10 minutes or so. And so that's the first way, just ingress tool transfer via that already established C2 channel. An additional way that you can do it is to pull it in via a wget cradle. So via Scythe, you're able to pull this what we call direct download links, which I'll show here in a minute. But with this, we're just going to run wget, which is going to pull down this campaign from the link. We're going to output it again inside that downloads directory. We'll just call it drop wget, and then we'll go ahead and tell it to execute that campaign. So a way you can pull the direct download link is, again, inside of this campaign view, click these three dots, direct download links, and then you have all the different links that you can just that you can pull down via wget in that same form or fashion and download it to disk. So if you want to exe or DLL, client host, there's a bunch of different ways you can download it. For this example, we just pulled down the exe because it's the easiest, right? That's the second way that we can nest a campaign. The third one is similar, same, but different, if you will. So we'll again run a wget command to pull down our payload. But in this one, instead of having that direct download link, we're going to host that executable in our public VFS directory. So the same virtual file system where we stored that PTE, or excuse me, where we had the PTE and then dropper.exe. It's the kind of the same form as that, but we'll download the campaign as an executable. We will put it inside of the virtual file system inside of public. And then from public, you're able to pull down anything inside of here as long as you're able to reach this URL, this demo dev unicorn craft. So it's kind of like your own place to host files or executables, things like that, that you're able to control.
So this is a kind of a good way of representative use of like redirectors or another site you stage out in the web that you're able to pull these droppers from. And that's kind of what we're trying to mimic here. We just included it all packaged for this sake right up in your Scythe C2 server. If you wanted to, you could change that direct path to have it go through a redirector as well, so that it doesn't look like it's coming straight from Scythe. It's coming from somewhere else.
For sure. Another benefit of using the public VFS as opposed to doing just using a direct download link is you can download the executable or the binary or the campaign, and then you can recompile it. You can run it through things like Donut or some other kind of evasion tools, and then put it up there, and then you won't have to download just kind of like the vanilla or default version of that campaign. You can make any modifications to it that you would like. So that one, I don't have it execute on this one because it already executes. We'll see here in a second. It executes like 15 times. So I didn't have it execute this one again. That's another way to download and execute that bit of the campaign. And then the next one, kind of away from using, like typical downloader tools or, living off the land, PowerShell, wget cradles, things like that. We're going to use a technique called process hollowing or a p-hollowing. So what this is going to do is it will take our campaign, which we downloaded as shellcode. You do that the same way we downloaded the other ones. You just click next to the one you want to download, click the download button, and click shellcode or shellcode DLL, whichever one. So from that, we'll download it. We'll put it in our virtual file system. We'll tell it to run in the background and that this is shellcode. And then here is where you tell it what process or what binary you want it to inject itself into. So this will take our drop.bin, our bit of shellcode for that campaign, and inject it into calc.exe. So we should see in the logs that calc.exe is the parent process of whatever drop.bin is doing, right?
That's probably one of my favorites from this list too. It's a really interesting one to see happen, especially during a PTE. A lot of customers don't expect it to work, and then all of a sudden, hey, look, there's a new implant.
Yeah, that one is definitely Definitely probably my favorite way to do it. It seems to get by a lot. Like if you're not catching that initial process hollowing attempt, you're probably not going to see the additional actions. And like calc.exe is probably a pretty obvious one, right? So maybe you want to inject it into an already running process or Chrome or MS Edge, because those have a lot of child processes associated with them. So calc might not be the best one for you, but just for this, for this demo, it'll suffice. And then over to the last one on this page, and then, or on this campaign, then we have another campaign that goes over one more technique. But for this one, we're going to run a binary or a PowerShell script. We're going to run sharphound.ps1, but we don't want to download it to disk and then run it that way. Sharphound is heavily signatured. I mean, by everybody, right? Everybody knows what it is. Everybody uses it. We see that adversaries use it all the time, so it's very heavily signatured. So one way you can kind of get around that is utilizing the IEX, which is to invoke expression. So what this is going to do, it's still going to call PowerShell, right? You'll probably see this command line argument logged. Maybe you could use upshell or PowerPick or something like that to kind of evade that command line detection or command line logging. But in this, we're going to call PowerShell, and what this is saying is go to this link here, which is the sharphound.ps1, which we have hosted on our public VFS. It's telling it, go to this link, download the contents of this string, and it's going to store all of it inside of this PowerShell session, right? So it's going to store it essentially in memory in this PowerShell session, and it's not going to write sharphound.ps1 to disk. So this is a pretty great way to kind of evade having to write binaries or write commands or write anything to disk, so it'll exist only in that PowerShell session. Once that session is done, it's gone, right? Here we do output the contents to a directory, so that will be logged, obviously, because that's going to be written, that's going to be written to disk, but the actual sharphound execution itself, you shouldn't see on the endpoint. And then the one additional way that we thought of after we made that campaign is to go in and inside, oh, sorry, I forgot that I made this one just a shell. Open it right here. So inside of the virtual file system, you're able to put PowerShell scripts, PS1 scripts in there. So I made just this kind of simple wget cradle that's going to run, which it's going to pull this direct download link here, output it again inside that downloads directory. This is going to tell it just to download it, wait 2 seconds, and then start that process. So it's able to execute. The reason we like this one is you're able to make your PowerShell script, your PS1, you put it in the virtual file system. You can use upshell, which is unmanaged PowerShell, to call this script and execute it again in memory. It doesn't write any of this to disk. The only thing that you should see written to disk is this file being created, because you can't avoid that, right? If a file gets created, it has to write something to disk, like that will be logged. But it'll write this file being executed, and that's it. When we were looking through the logs, you don't see any of this in script block logging. You don't see it as a process creation. You don't see the command line arguments made. The only thing you're able to see from this is that that file was written, right? So instead of trying to run each of these as individual command line arguments that'll all be ran, you could just make a script, put it in the virtual file system, call it via upshell, and then it's a little more stealthy, right?
And that goes back to a lot of what we teach in the workshops too, of paying attention to state-based stuff as opposed to like keyword searching and things like that. Like the new file being created is something that did change. It's something you can notice.
Yes.
We could change the name of Sharphound to something else, and then all of a sudden your detection's no good, right? So it's just an interesting way to go about doing these things.
Yeah, 100%. Then we'll just kind of show you what that looks like inside of Scythe, just with the request and response from it. So again, initially we want our first campaign, our dropper campaign, or our initial, the biggest egg in our Russian little egg dolls that we have going on there. We wanted just to do some host enumeration, make sure that we're on the right place, that we're able to reach the internet, get some host info. So just a simple who am I, run system info, get lot more information, and just make sure we're able to reach Google, make sure we're able to reach the internet. From there, it'll do that first one, which is the direct download or the ingress tool transfer via C2 of that dropper.exe, which is again inside of the virtual file system. Downloads it, calls it, that'll execute, right? And then the next one, we have that wget cradle, which will pull it, download it into downloads dropped wget.exe, and we tell it to run the same way. The reason for this ampersand here is it's supposed to run it in the background so it doesn't tie up the terminal. And then onto the next one, again, very similar, just a wget cradle to download it, but except for it being the direct download link, it's pulling from the virtual, from the public folder in the virtual file system. And then process hollowing here, we could see that it was successful. We could see what the PID is of the shellcode that we injected into it. So we're able to tell that process is running, right? And then here we could see this is when we run sharphound via IEX, which again will put it inside of that PowerShell session. So it shouldn't really write much of anything to disk outside of these files. But in here, we'll even return everything that it looked through and was able to run, and then tells you happy graphing at the end. I just love that. And then from the nested up shell, we kind of saw it to see it's only writing that the file was downloaded here because I tell it to with the right host just to kind of make sure that it worked. Excuse me. And yeah, and that's kind of that's how those campaigns will look. That's how those campaigns will look from like a request response side of it. And then I'll just show quickly what our dropped campaign looks like. So this was meant to be a very small ransomware emulation. So it'll make a directory of ransom, put a bunch of dummy files in it, compress those files, upload them, and then encrypt everything inside of that ransom directory, right? So this is akin to double extortion ransomware, where they will exfil your unencrypted files, so that way they have it to say, pay me, or I'm going to release these unencrypted files to the world, and then they encrypt it, and they say, pay me, or you're not going to get your files unencrypted, right? So double encryption ransomware there.
Yep. And again, these are just kind of simple examples for everybody to kind of catch what we're doing here. But in reality, we've shown them several different ways of pulling in, loading a secondary mechanism for C2 or a dropper implement, whatever it is you happen to want to pull in. We've shown them from like non-stealthy means, just doing it normal PowerShell. They've seen a little bit of stealthier side, doing some cool things like process hollowing, or just using unmanaged PowerShell in general to pull and execute. So you've got plenty of options here when you're using the platform to actually perform these emulations.
Yep, for sure. And again, obviously Trey and I work at Scythe. This is the Scythe Threat Thursday Live that we're doing. You can do this outside of just Scythe and the platform. Whatever tool that you have or are utilizing now, you should be able to run some kind of nested campaign like this. So I would encourage that you just try it out, try some of these means, and see how differently it's logged, and if you're able to detect it in the same way that you're able to when it's just a single campaign or a single binary that's being executed, right? And from there, real quick, we got about a minute left or so till we hit time. So I'll just kind of quickly go over some of the, maybe not detections, but what we see in the logs, right? So the first one, we said you can't avoid that file being written to disk if you're downloading it to the disk, right? Again, focusing on those state-based detections is really just a much better way to perform your threat hunting. So the first way that we do it is just by looking at file creations by image. We cheated a little bit because I know what these are called because I wrote them to disk. But if you were just looking at files created by PowerShell, it listed out all of our droppers here, and then from there you could go ahead and set those as the image and see what that had dropped, right? So all of our droppers are the ones that have the nested campaigns inside of it. So we could see that dropper 3 had written to this drop.exe, dropper.exe, wrote dropped, net sh upshell 1, dropper upshell, so on and so forth. So a good way from there, again, focusing on like PowerShell and CMD and things like that, and seeing what what's strange with them is really a great place to start if you're not sure. And then next up, so now that we know what what was downloaded, we know that these files are suspicious. Let's see what command line arguments they were running. So in here, we're just looking at the images we have set to the either the drop or the dropper3.exe. We can see some command line arguments being ran here, like dropper3 is calling PowerShell. We can see that wget cradle. We could see it executing dropped and drop wget. See another wget cradle, and we see that IEX command in here, because again, those command line arguments are going to be written, but we're not going to see the command lines of what sharphound.ps1 was able to run.
What's
And then
interesting there is that dropper3 calling calc.
I was just about to say, I was like, and then we see here that something is interacting with calc.exe, that this dropper3 was downloaded from PowerShell and is now talking to calc. That's kind of strange. Might want to check that out and see kind of what's going on. And then we also see that just our initial campaign here of it running just our initial steps or initial enumeration. And then down, I like to use this app in Splunk called PS Tree listing. So basically, it will give you a process tree of the campaigns that were, or excuse me, give you a process tree of the parent processes and child processes underneath them. It can make it very enlightening or illuminating into what is being launched by what. A lot of EDRs will do this kind of on their own, but it's like a graphical interface you have to click on. I don't really like that as much. I like to just see it all at once, and we don't have an EDR in our lab. We just run Sysmon. So just in Sysmon, you're able to come up with this if you use that app. But you can see that PowerShell is called here by SVC host, and that then it's running this upshell one. Under upshell one, it's running who am I? We can see that all of these here are being launched by PowerShell. Just kind of another way to have a look at it. So we see here that this is what PowerShell is doing. You see underneath we have dropper2, which then talks to calc. Calc will then spawn PowerShell, which then runs net upshell1.exe. So again, like looking at the parent and child processes, it makes it a lot easier to kind of detect when things are anomalous, right? If you like Trey said, you see calc running from PowerShell or calc that then is running PowerShell and running all of these other pieces, probably something that should be investigated. Maybe even put some logic into it where if calc spawns, X amount of child processes to get an alert, right? Something like that. And then still the same thing basically that we see here from PowerShell, just running additional campaigns underneath it. You could also, this is a little bit harder to see, especially because I'm really zoomed in for this part of it, but it's the same thing that we ran before, except it has all of the command line arguments associated with it. So we see that PowerShell launched dropper3 launched PowerShell.exe, PowerShell.exe ran this command. You can also see that dropper3 called out to calc. We see that it called out to PowerShell again to do that wget cradle, another to have it run underneath it. So just another way to kind of see, like here you can literally see how it's nested, which is what we're talking about, right? You can literally see how these all fold into each other. Back up, you're able to see all of the command line arguments that they ran as well. Again, it's a little difficult to see in this view just because I'm so zoomed in, but when you zoom out a little bit, it's a lot easier to kind of make out everything that it's doing. I would say normally the longer the tree, the more suspicious it is, right? You shouldn't have great grandchildren processes, or you shouldn't have one process unless it's like SVC host, like that's pretty normal. But PowerShell shouldn't be relaunching PowerShell, relaunching CMD, relaunching executables, things like that. You shouldn't have one, two, three, let's say 12, child processes all associated, 12 child processes / grandchild processes associated to just PowerShell.exe, right? So you could tune that logic to really focus on even having X amount of child processes or something like that should be enough to at least tip you off to some suspicious activity and should prompt you to investigate it. So that was me going over it in exactly 1 minute, I'm sure.
Give or take 5.
Yeah, give or take 5 or 6.
But yeah, so that was pretty much what we had to show you guys today, talking about nested campaigns utilizing Scythe to kind of kick off other emulations or other campaigns to really show a full fledged kill chain. If you're curious to see this all in action, check out our workshop or playlist. Down there, we have one that was a joint workshop we did with the guys over at BC Security, where we show utilizing Scythe and Empire and Starkiller in tandem to pass campaign phases back and forth throughout an emulation of Fancy Bear. So that's a really cool example of seeing this work actually live and doing the full kill chain. Outside of that, we will see you guys again here, I think, in what, 2 weeks, right, Tyler? Where we'll be talking about some interesting ways to do lateral movement with Scythe.
There we go. Yeah. So it should be fun. Hope to see everybody here in 2 weeks, and thanks everyone for hopping on.
Thanks for participating. Talk to you later, guys.